In this lesson, we're going to look at how to prove congruent triangles using the addition and subtraction theorems. So the first thing here is let's look at our givens and let's look at which triangles we're trying to prove. So when I look at this picture, I see multiple triangles involved. So really the first thing I want to do is just look at which two triangles am I trying to prove are congruent. So let's go ahead and get those highlighted. So I have ACD, so triangle ACD. I'm trying to prove that's congruent to BCE. And now I'm going to go ahead and start marking my givens and writing those down. So I have AE is congruent to BD. So AE, so this whole thing is congruent to BD. And notice I'm not marking like a slash in here just because it'll be hard to see which segment I'm talking about. So that's why I'm writing it underneath with these brackets. So it's that entire AE is congruent to segment BD. Then I have AC and BC are congruent. Notice now I'm using two slashes because I've already used single slashes to represent the lengths below. And then I have CD is congruent to CE. So right now when I look at this, I'm seeing that I have two sets of congruent corresponding sides. So it's kind of indicating that I should be using something with sides as my congruence theorem for why these triangles are congruent. And then I look at this other given and I ask myself, why would they tell me that these two segments that are not part of the triangles are congruent? So how can those help me get congruent parts in the two triangles I'm trying to prove? So when I'm thinking about my addition and subtraction theorems, or even if I wasn't thinking that way, I'm looking at this whole segment is congruent to this whole segment, and I'm seeing that that would help me get these segments right here. It would help me get AD and BE because I have this shared piece, DE. So if I were to say, okay, well, AE, that whole thing is congruent to this whole segment BD, if I subtract off the same piece from both of them, doesn't that leave me with AD and BE being the same thing? So that's kind of where I need to go with it. I need to show that those parts are congruent because I started with congruent wholes and I could subtract off congruent parts and I'll be left with congruent parts. So the red flag there was knowing that the large segments were touching the smaller segments or the smaller sides of the triangle. So let's go ahead and let's write these givens down. So AE is congruent to BD. So that's given. I have AC is congruent to BC. So that's given. And I have CD is congruent to CE. So I'm looking at this, and since I know I'm going to be getting these sides down here, this is going to end up being side, side, side. So for my outline here, it's going to be side, side, side. If we look at what we already have, be careful here because it looks right now that I have three sets of sides that are congruent. But if you actually check these, side AE and BD are not part of the triangles. So that I can't check off a set of sides for those. But for these other ones, these are sides of the triangle. So right now, I really have two sets of sides. I don't have the third yet. So what I'm going to do, in addition to this given, is I need to mention that I have reflexive property. So reflexive property is going to be used as my other congruent parts so that I can subtract off. So what I'm going to do is I'm going to take this set of segments, the wholes, and I'm going to subtract off DE from both of them. So that's what we're going to subtract off. So that means I need to write that. So this is really, so what I'm going to do, I'm going to write it underneath it just for space, but really my reflexive property should be up with my givens. So I have DE is congruent to DE. That's by reflexive property. And then what I'm going to do is I'm going to take those two things and I'm going to subtract them. So if I take AE and I subtract off DE, so AE minus DE means I'm going to be left with AD. And then if I take segment BD, this whole thing, and I subtract off DE, I'm going to be left with BE. So this is the segment subtraction theorem. And that gets me now that these sides here are congruent because I took congruent wholes and I subtract off congruent parts, and that left me with congruent parts. So now I can check that off, which leads me to say that using these three sides, so this is the S, S, and S, I can say now that the triangles are congruent. So now I can say triangle ACD, triangle, is congruent to triangle BCE by side, side, side. And that's it. So I use one of my mini proofs or my segment subtraction theorem to help make a conclusion to prove that these triangles are congruent. So let's go ahead and try another one so you get the hang of it. So looking at this one here, again, I see a picture with more than two triangles. So let's look at first which triangles are we trying to prove. So I'm trying to prove ACD. So again, ACD. Trying to prove that that's congruent to BCE again. So it's the same scenario as above. But the difference is what they give me. So looking at what they give me, I have some things to mark. So I have angle ACE. So ACE. So this entire angle is congruent to BCD, is congruent to this entire angle. Then I have AC is congruent to BC. And then I have CD again, and I have CE again. So now I'm looking at this and I'm thinking side angle side because I have two sides and I have these angles up top here, but I can't jump into saying side angle side yet because of the fact that I don't know that this part is congruent to this part over here. So what I do need to do is show that because these whole angles are congruent and because I have this shared piece right here, I could subtract that purple piece off, and then I would be left with this piece right here. So I'd be left with that and this being congruent. Because if the whole things are congruent and you subtract off the same thing, or you subtract off this congruent part, then that's going to show you that the other pieces are congruent. So then this is going to be side angle side, because now I'll have the angle in between the two sets of sides. So let's go ahead and write down our givens. So I have angle ACE is congruent to angle BCD. And I'm going to just number this one angle here, angle DCE. I'm just going to number that angle 1. So right there represents angle 1. And then I'm going to call this angle 2, and I'm going to call this angle 3, just so it's easier to talk about them. And then, so this was given. I have my other givens here. So these other givens represent my two sides, my two sets of sides that are congruent. I do need to work on getting the angles, because remember, these big angles are not angles in the two triangles I'm trying to prove. They're angles in some of the triangles, but not in the blue and yellow, which I'm trying to prove are congruent. So that's why I have to work on getting angle 2 congruent to angle 3, because those are actually angles in the triangle I'm dealing with. So what I'm going to do is I'm going to take this set of angles here, and I need to subtract off angle 1 from both sides. Because if I subtract off angle 1 from both sides, it's going to leave me with angle 2 and angle 3, because it's the same part. So what I need to do is I need to say, first of all, that angle 1 is congruent to angle 1, showing that it's shared between the two larger angles. And I need to say that it's congruent to itself so that I'm showing I'm subtracting off congruent parts. So this is my reflexive property because it's shared. So again, this could be up here with the givens. I just don't have the space. So that means these two are going to get linked together, and I'm going to use the angle subtraction. So I'm taking the whole angle and I'm subtracting off angle 1 from it. So when I take the whole angle here and I subtract off angle 1, I'm going to be left with angle 2. And when I take this whole angle, angle DCB, and I subtract off angle 1, I'll be left with angle 3. So I subtracted these is what I did. And then that is the angle subtraction theorem. So that gets me my set of congruent angles. So now by side angle side, I have everything mentioned in my proof. So now I can piece together the sides and the included angles and say that triangle ACD is congruent to triangle BCE by side angle side. So let's try one more together. So if we go to the next page, we have a different looking scenario. So again, let's look at which triangles we're trying to prove. So I'm trying to prove triangle ABC. So triangle ABC is congruent to EFC. And then let's go ahead and mark what they give us. So they're giving us angle BCD. So this entire angle is congruent to FCD. So this entire angle over here. They tell us angles 2 and 3 are congruent. And then AC is congruent to EC, and BC is congruent to FC. So when I'm looking at this, I see that these two sides right here are sides in my triangle. So those are going to serve as my two sets of sides. And then the angles in my triangle, I see all this mess here. So I see the big angles, and then I see two smaller angles are congruent, but I don't know right now that the angles in my triangle 1 and 4 are congruent. But again, the red flag here is the fact that they're giving you all of this other stuff that's touching those angles 1 and 4. So most likely you're going to be trying to prove 1 and 4 are congruent, since those are the angles in your triangle and they're touching these other congruent angles. And then if I knew 1 and 4 are congruent, well, then I could use side angle side. So in order to get angle 1 and 4 are congruent, we could use the fact that these whole angles are congruent, and we have congruent parts that we could subtract off, which would mean these pieces right here would then be congruent. So that's what I need to do. So let's go ahead and write our givens down. So we have angle BCD is congruent to angle FCD. And then we have angle 2 is congruent to angle 3. And we have AC is congruent to EC. And then we have BC is congruent to FC. So lots of givens. So right now in my proof, I have my two sets of sides. So now I have to work on getting that pair of congruent angles. And remember, since I know that these whole angles are congruent, if I subtract off 2 and 3 from those, I'll be left with 1 and 4. So basically, if I take these two statements, I subtract them, what that's going to do is it's going to, if I take the whole angle, BCD, I subtract off angle 2, I'll be left with angle 1. If I take the whole angle FCD and subtract off angle 3, I'll be left with angle 4. So I can say that angles 1 and 4 have to be congruent by the angle subtraction theorem. And then that lets me mark my set of angles. So now the set of angles in the triangles here are congruent. So now it's by side angle side that the triangles have to be congruent. So take all three pieces for the side angle side, so the two sets of sides, the angles between them, merge those together, and you get triangle ABC is congruent to triangle EFC. And that's by side angle side. So there you go. So you have some different examples on going through these, and when you return to class tomorrow, we'll do some more practice with these. So I don't have any check your understanding problems for you But I want you to just be ready to do some more practice in class tomorrow.